Assalamu alaikum warahmatullahi wabarakatuh. I have received questions about how to remove the effect of matrix on target analytes, and this is a very important question. That's why this lecture will be only the answer for this question. Before that, you should know that with every batch of samples you will analyze, you need to run quality control samples to ensure the accuracy and the reliability of your results. One of them, which is reagent blank. Reagent blank is a very important sample to find out if there is any cross-contamination happening during your extraction steps or not. You will use only the extraction solvent that you use already to extract your target analytes, and this extraction solvent will take all steps of extraction, same like your samples, exactly same, and then after you will analyze the samples. If you get any response in this reagent blank, you will subtract this response from all of your samples in the sequence to get the accurate results for your samples. After that, you have spike sample, which used to assess the efficiency of the method, and that will be by fortification of blank sample. This blank sample should be clear from your target analyte. You will make spiking for this blank sample with known concentration of the analyte of interest, and then you will calculate the recovery. Recovery will be equal to practical concentration divided by theoretical concentration multiplied by 100. The result of recovery should be according to the guideline use. As example, if you use Eurochem guideline, there is from 70 up to 120%. Codex also, you will find this. According to your method, your analyte of interest, you will find the exact recovery that you can use. If you use from 70 up to 120%, as example, if you find out the practical, if you spike 20 ppb, theoretical concentration, and you get on the instrument 18 ppb, in this case you will multiply 100, your recovery is 90%, and this is accepted. So there is no problem with your method, and your method is efficient enough and can get accurate and reliable results. Okay, but if you, as example, find out that if you spike your sample with 20 ppb and you get, as example, 9 ppb on the instrument, in this case your result will be 45%. This is not accepted at all, so you should repeat the work again. You should stop the work and repeat again. So during your routine analysis, if you didn't get the accepted recovery, you will repeat your extraction steps from the beginning to the end to check if there is any mistake or not. And in this case, your samples will be repeated also, because this mistake will be in all of your sequence, not only with the spike sample. Now we will go back to our subject for lecture today, standard matrix sample or matrix effect sample. This sample used to remove the effect of matrix on your target analytes. Effect of matrix, it can be by enhancement or suppression. It can make enhancement for your results, means increase the concentration of your samples, or suppression means suppress or reduce or decrease the concentration of samples. So you need to add one more sample to remove the effect of matrix on your target analyte, which is a standard matrix sample. And this sample will be prepared from the blank sample, same blank sample that you use to prepare your spike sample. You will add known concentration of your target analyte, known concentration, as example on the blank sample. After extraction, after all extraction steps, at the end of your extraction steps. As example, if you want to add 20 BBB on 1 ml HPLC vial 1 ml, in this case, from 1 ppm, you will prepare from 1 ppm your standard, you want to add 20 microliter. You will add 20 microliter from your standard, which is 1 ppm, from your standard 1 ppm standard, plus 980 microliter from the blank sample after extraction on HPLC vial, and then you will run. After you will run, you should have as a theoretical concentration, you should have on the instrument 20 BBB. But if you get practical concentration on the instrument 10 BBB, as the example, in this case you will correct the result and by calculation of correction factor. This correction factor equal to theoretical concentration divided by practical concentration, 20 BBB divided by 10 BBB equal 2. This is your correction factor. Then you will multiply this correction factor in all samples, even in your matrix spike sample. Another example for this point to make it very clear, if you will spike your sample, you have blank sample. This sample we said that should be clear from your target analyte, and you will spike your sample with 10 BBB. This your matrix spike, 10 BBB. Your standard matrix sample or matrix effect sample you should get the same concentration on the instrument like your matrix spike to be easy to calculate. So you will also add 10 BBB on blank sample. Here in this case, it will take all extraction steps, this sample, matrix spike from the beginning to the end. Blank sample also will take all extraction steps. For standard matrix at the end, you will spike your sample with 10 BBB. So in 1 ml HPLC vial, 10 BBB multiplied by 1 ml, from 1 ppm you need to add 10 microliter. You will add 10 microliter from your standard 1 ppm plus 990 microliter to complete to 1 ml in HPLC vial from your blank extracted sample. After you will analyze and you get for matrix spike as example 4 BBB. On the instrument you find the result for matrix spike, it should be 10, it came out 4 BBB. And for standard matrix should be 10, you get 5 BBB. Before you will calculate the recovery, you will calculate correction factor, because this correction factor will be multiplied with all of your samples and also with matrix spike. Correction factor, as we said before, theoretical concentration divided by practical concentration 10 BBB divided by 5 BBB equal 2. This correction factor will be multiplied on this concentration. 2 multiplied by 4, so your spike equal to, the real concentration for your spike equal to 8 BBB. This is the real, and your recovery equal to 8 divided by 10 multiplied by 100, 80%. This is accepted recovery. So now you remove the effect of matrix on your target analyte from every sample in this sequence by calculation of correction factor that will be multiplied to matrix spike and other samples too. This was the answer for your question. I hope that was easy for you to understand. Don't forget to share our lectures and subscribe our channel on YouTube. See you in the next lecture inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.